This is how-to videos, force example 2A, net force. So we have someone pulling on a lab cart. Let's point out the important information here. She's going at a constant rate. We've got pulling it with 200 newtons. I'm sorry, it's the cart is 200 newtons. The pulling force is 55 newtons. We're looking for the frictional force and the normal force. So we first go ahead and draw out the diagram. We've got a gravitational force, which is downward. We've got a normal force, which is upward. We have an applied force to the right and the frictional force to the left. Listing out the information. Do I know anything about the mass? Well, not at this time. I could solve for it if I wanted to, but we'll see. I've got force normal is unknown. I've got gravitational force. I've got applied force and frictional force. Okay, so I do know that the applied force is 55 newtons. And the 200 newtons, let's see, that's describing the cart itself. So, this is supposed to be gravitational. So that would be the 200 Newton cart. Okay, so I'm looking for the frictional force and the normal force. It doesn't really matter which axis I start on. Let's go ahead and begin with the normal force. So that would be the y-axis. Sum of the forces on the y-axis equals mass times acceleration on the y-axis. So what are the forces on the y? Well, I've got the normal force and I've got the gravitational force. I notice the normal force is going upwards and the gravitational force is going downwards. Because we treat downward as negative, we're going to subtract that, and that's equal to mass times acceleration on the y. Now we say, is the cart floating up into the air? Is it falling down through the ground? No, so the acceleration is 0. That means the normal force equals the gravitational force, which equals, let's see, 200 newtons. Okay, so that means my answer for the normal force right here is going to be 200 newtons. Yay. Now I'm looking for the frictional force. Frictional force is on the x-axis. So once again, sum of the forces on the x this time equals mass times acceleration on the x this time. So I've got applied force and I've got frictional force. I notice the applied is to the right, which we normally treat as positive. Friction is to the left, which we normally treat as negative. Now, I had decided them that way, but I usually say that friction is going to be a negative force because it is opposite of the direction of motion. So that equals mass times acceleration. Now, is it accelerating on the x-axis? Well, we already pointed out that it is going at a constant rate. So that means the acceleration is 0. Therefore, the acceleration the applied force is equal to the frictional force, which we know from before is the 55 newtons. So frictional force is simply 55 newtons. You say, wow, that's so easy. I could have figured that out from the beginning. That's because there was no acceleration and there's only 2 forces on each axis. They can get more complicated. Stay tuned.